Okay, there are a couple of terms I mentioned before, and I was going over the testing. I mentioned reliability and validity, and these are very, very important terms. And tests are tested themselves for reliability and validity. With some of the research that's done is research actually on tests to make sure they have these, to see what level of reliability and validity they have. And what do I mean by reliability and validity? Okay. Well, reliability, what do we mean by that just in general? If you have a friend that you see as reliable, so if you agree to meet for lunch at 11:45, that they're usually there. They show up, and they're there about 11:45, right? That would be someone that you can rely on. In testing, that's sort of what we mean. We're looking for consistency. So, does the test give consistent measures from one time and place to the next? If I give you an intelligence test today, if I give you the same test a year from now, do I get similar kinds of results? That's assuming that everything's pretty much the same for you, okay? Do I get similar kinds of results? If I do, then I would say that that test was reliable. Okay. An example I like to give is what you see in that picture. If I get on a scale, a weight scale, okay, and it says 130 pounds, and I get off and I get back on, and it now says 82. I get off, I get back on, it says 205. I get off and get back on, it says 47. Okay, what would we say about that scale? It's broken, right? It's wrong. It's unreliable, right? It's not consistent. Okay, so that's what reliability is. And a test is no good if it's unreliable. Okay, you just pitch them out. Okay, so that's the very first thing about a test is if it's unreliable, we can't use it whatsoever. The next one is validity. Does a test measure indeed what it says it measures? Okay, now I mentioned intelligence tests. Do intelligence tests indeed measure intelligence? Well, that's a big controversy. Okay. There'll probably be many psychologists that say, well, intelligence tests do measure some kinds of intelligence or certain aspects of intelligence, but there's concerns about bias with these tests. Okay, so the Beck Depression Inventory, does it measure depression? Yes, indeed. It's been tested. It's a good test for that. It has good reliability. It has good validity. It does indeed measure depression and not something else. Okay. If I got on that weight scale and go, oh, 130, oh, that's great. I've got above average intelligence. Okay. I'm using that scale in the wrong way, right? It's invalid. It's a weight scale. It's not an intelligence scale, right? Okay, that would be an invalid use of it. So validity is also very important. Does my anxiety test indeed measure anxiety and not something else? Okay? So those are two terms that you should definitely know and remember. Okay, so let's do a quick quiz. What are the goals of psychology? There were several of them. What do we call an in-depth research study of one person? Or it could be a small group who went through some very interesting experience. Going undercover to study a particular group of people is what kind of observation? What are some ways we can deal with observer bias? And can we use case studies to generalize to other groups? All right. So I'll let you double check those for yourself. I think a lot of these you can find the answers to. You can review your notes and find the answers to, but let me go over number 4 a little bit. Ways to deal with observer bias. I mentioned a few things. One of them is to have more than one observer. So that's why it's so nice if you can have that laboratory setup where you've got cameras and you can review, more than one person can review the tapes, or you can have more than one person that's behind the mirror and can watch the kids as they're in the playroom. So you can have that. The other thing about dealing with observer bias, like I said, is to have that checklist and be very careful about what you put on that checklist so that you're not just narrowly looking for one thing that you're expecting to find, okay, that you're looking at a variety of behaviors. Okay, so that's another thing to help you with that. And probably the key thing is to be aware of what your biases are. Okay, and that's a really hard thing to do as human beings. We have big blind spots when it comes to that. So that's why it's very helpful to have colleagues that you can bounce ideas off of, that you have people check your work, that you think things through, and you also do some self-reflection. That's always very helpful. Okay. All right, next we have surveys. I think you've probably encountered this. Either it's someone trying to reach you on your phone to get your opinion about a product or a variation of a product, a candidate for an office, a political office. And you see more of these around election time, right? How are you going to vote? Very popular kinds of questionnaires and interviews, but you get these all the time. One that is very common in school is asking you to fill out a questionnaire about how you're evaluating the courses you take. And I'll refer back to that in a little bit. So surveys can take the form of questionnaires and interviews. These can be very similar in a way. Questionnaires typically are the ones that are written, whether it's someone at a shopping mall who's got a clipboard and is do you mind taking a few minutes to answer some questions kind of thing? Or it's one that's online. SurveyMonkey is a good one, right? Or an interview where someone face-to-face is asking you questions or calls you on the phone and asks you questions, where it's a person talking to a person. Is typically how we describe an interview. Okay? But both of those are surveys. Now, one of the things that's very important for surveys is, if we're going to use the information, is that the small group that we're talking to represents the larger group we're interested in. Okay, so for example, when we're interested in how people are going to vote for, say, the President of the United States, that small group that we talk to indeed represents the entire United States. So think about the kinds of groups that we need to include for that. If you only talk to people in one county of one state, is that representative? More than likely not, right? There's regional differences. One small county might be overly Democratic to the Republicans, over Republican to the Democrats. And so have different biases. You might have a group that is predominantly of one socioeconomic class, say working class or uber wealthy, right? Do they vote differently from each other? In many cases, that seems to be so. So we want to be careful of that. And to give you another example of that, just in regular life, when you are in a big box store like Costco or Sam's Club or something like that, and you're walking towards the back, there's these nice people that have a table, and they've got little cups or plates of items that they want to give you for free. Okay, what are those called? It's called samples, right? Those are samples. And why do they give them to you for free? Well, because if you like the sample, maybe then you'll go ahead and you'll buy the quart of pimentos or whatever it is that they were selling, the peach cobbler, the ice cream, the Hot Pocket, whatever it is that they were putting out there for you. Okay. Well, what I'm describing as far as representative sample is similar to that. What if the sample was 7-layer dip, and all you got was the sour cream as your sample? Would that be representative of that? So when we have a sample from a population, we want to make sure that we also have the guacamole and the refried beans and the salsa. We want all 7 layers, even a little shredded cheddar cheese at the top, right? We need all of those layers in order to have a representative sample for the entire population. Why don't we just survey the whole population? Well, it's too expensive and it's too time consuming, so that's why we don't. And also, if you have enough people in your sample, it's going to do just as well anyway. Okay, there are some people who seriously think we should stop conducting the American census every 10 years like we do, because the census does indeed try to get everybody. And there are a lot of people who think that's really too time consuming and too expensive, that we could do a darn good sample and get just as good results. Maybe. But that's not in our Constitution, so we're still doing it the old-fashioned way. So one of the things that we need to be careful of, there's a couple of things about surveys we need to be careful of. One of them is volunteer bias. Okay, if you have a really long survey, or you're going up to people who are really busy, okay, the people who bother to fill out your long survey or to stop and give you the time to spend with talking to you, okay, they may be a certain type of person, okay? And so when we talk about volunteer bias, and that goes along with another term called response rate. If I can... Okay, so you're looking at the level of responses you have, and if you have a low level of responses, that's a clue. If you're seeing a study where they have a low response rate, red flags should be flying for you, because what that means then is that compared to the number of people who could have filled out this survey, who could have answered the interview questions, very few did. That means then that the very few who did may have a bias. Okay. Think about some things like Yelp reviews. Okay. Who bothers to take the time? Now, there's a lot of people who might have no problem with a lot of reviews that are online, like hitting the 2, 3, 1, 5 stars, right? Okay, doing that. But as far as writing something out, not so many people do that. When you read what people write out, what do you typically see? And this is true of course evaluations, okay? So faculty go through this too, okay? Students may go ahead and fill out where it's just real simple and you're just, tapping things about, boom, boom, boom. But when it comes to actually writing things out, most people don't bother. And those who do are saying what? I love this or I hate this, right? Usually it's the extremes, okay? You don't get a whole lot of people going, it's all right, okay? You just don't. You tend to get extremes. So that's why you got to be very careful in looking at results of these things. What was the response rate? Because if it's low, more than likely then you may have a bias of who bothered to fill it out. If it was really long, very time consuming, if they're bothering to write things, there's a bias probably there, and you got to be careful of that. The other thing we got to be careful about with surveys is just how do you craft the questions? And there are ways that people can write questions where they're kind of pushing people one way or another, okay? You'll see this with like Republican and Democrat survey forms where they're asking pretty much the same thing, but depending on how you describe it, you tend to get different kinds of responses. Questions about, say, welfare reform. Should people receive government funding when they don't work? Okay. Compared to, do you think poor children should be supported by the American government? Essentially asking the same thing, because the vast majority of people who collect welfare payments are poor children in the United States. Okay. But depending on how you word it, you tend to get different kinds of responses. So that's one thing to be very careful of, is how survey questions are created. But also when it comes to how people respond, depending on what's being asked, you can have different kinds of reactions that may be problematic. Okay. We don't even bother to ask teenagers anymore, have you ever cheated on a test? What's better to ask is, like, what percentage of your classmates do you think have cheated on a test? Or in the past year, or whatever, okay? That's easier to respond to. Very often people may lie deliberately, or they might fudge things a little bit, partly because they want to look good. Even if it's an anonymous test, if you're asking questions that relate to things like racial attitudes or sexual behaviors, people may just try to give what's the socially acceptable response rather than what's true for them, because As human beings, we just kind of want to look good, even if it's anonymous. You might ask people questions that have to do with the past, and they might misremember. Okay? Young women, you go through this all the time whenever you go to a doctor. What's the thing that you're supposed to remember? When was the first day of your last period, right? And, okay, get out my calendar, or what, and it's like, it was a holiday, right? Wasn't it? But can you imagine if you're asking questions about people in their past, how they might just misremember when exactly it happened. Okay. And also the survey questions themselves, they might misinterpret them. And that might be your fault because you didn't write the question very carefully, or it might be that you didn't think it through. And that's why it's always a good idea to test your questions with people first. Ask them what they think they mean before you come up with your final survey. All right. Now, once you get a lot of data from your survey, you can use that data and make comparisons. And one of the kinds of ways that we do this is with what's called correlational research. With correlational research, we have two sets of data, and we're comparing to how they relate to each other. And so that's why it's co-relational. Two things, how they relate to each other. And so there's a couple of things that we're looking at in particular. We're looking at the direction of the relationship, and we're looking at how strong the relationship is between these two sets of variables. So let's look at direction first. With direction, we talk about positive and negative correlations. Positive correlation means that as one set of variables, the values increase, the other set of variables, the value also tends to increase. So as you see here with the top one, you've got grades and hours studied. Okay, so if we, and by the way, what's on here on this slide is made up. So if we ask students what was, or if as a prof you had the scores, the percentages of a test, and on the test you also ask the students how many hours did they study, and let's say they were being truthful about it. Okay, you could correlate for each person. Each of these points is a single person, a single student. Okay, and you would plot out for each student, okay, what was their score? So this is like maybe what, 65%, and looks like maybe about what, 3 hours of study here, compared to grades that were above 90%, looking at their studying was more like at least 25 hours, right? Okay, so we're looking at this one, the lowest score, fewer hours. This one, the higher score, more hours, okay? When you see scores that are like this, where it's going like up like that, just by looking at it, you know that that's a positive correlation. I want to caution you. When you hear the word positive, don't assume, oh, that's good, it's positive. That means it's happy, it's wonderful, it's terrific, it's a good thing. No, it's not necessarily that. It's just a term, okay? It's just called positive correlation because as one increases, the other one also tends to increase. They're going in the same direction. You could say the other way around too. As one sets of values decreases, the other one also goes down, okay? They're just going in the same direction. That's a positive correlation, but it doesn't mean it's a good thing necessarily, okay? Negative correlation, again, doesn't mean it's bad or anything. It's just what it's called. Negative correlation means that as high values of one variable are associated with low values of the other. So as one set of values are increasing, the other set of values tend to decrease. So again, this is just a goofy one, but if we compared the scores on the test with how many beers they drank the night before, okay? And so we have higher scores above 95% with less than 5 beers. Again, each of these points is a single individual score, okay? And those that drank more than 10 beers, here's an individual with more than 10 with the lowest score, okay? So you notice that how it's going this way on this chart, it's a negative correlation, okay? Now again, it doesn't mean, this example means like it's a bad example, but negative correlation by itself doesn't mean it's negative. It just means they're going in opposite directions, okay? high scores associated with low. Okay. All right. This R that you see, okay, that's a correlation coefficient, and it indicates the direction and the size or the strength of the correlation. So typically what you'll see, like you have here, you had, it says R 0.89. Ideally it would have like a plus 0.89. If it doesn't have anything, you can assume it's a positive. Here it had R negative 0.74. Okay, that's a correlation coefficient, that R. Okay. And it's telling you a couple of things. One of the things it's telling you is, see the negative? It's a negative correlation. Positive, it shows nothing, or it's positive. Okay. This one is showing our 0.97 here. So we've been talking about the direction. What we're now going to talk about is the strength. Okay. The strength is how much are they aligned with each other. Okay. And it goes from -1 to +1. The strongest possible relationship you can have is absolute 1. Absolute 1 is either -1 or +1. Okay? Again, remember, negative doesn't mean bad, positive doesn't mean good. It's just, are they going in the same direction or not? Okay? But the strongest possible relationship you can have is 1, positive or -1. Therefore, the weakest relationship you can have is 0. Okay? That's the weakest relationship you can have. So I've got kind of a jokey one here. Notice if we were going to plot out the scores, your SAT scores and toe size, okay, we'd expect that there's probably no relationship between the size of your toe and what your SAT scores are, okay? And notice that these plot points are just all over the place. I can't do a this or a that with this, right? It's just all, it's all over the place, okay? So if you saw a scatter plot like this where you can't make heads or tails of what direction it is, just by looking at it, you can tell this is a very low size correlation, okay? A very weak correlation, right? Here, with this one, we've got a very strong correlation, and this actually came from an actual study. I think this is kind of funny. It's kind of fascinating. What they're looking at is the total U.S. highway fatality rates, okay? So higher is bad, lower is better, okay? And the metric tons imported of fresh lemons from Mexico into the United States. Okay. We have a very high relationship here, okay? 0.97. Now, what they don't have, okay, so what we've got here is the more lemons we import, okay, closer to 550 metric tons compared to 200, the lower fatality rate we have. Okay, so they don't show it here. This isn't done right. They should have a negative. So this is a slightly different way of doing it, but the way I'm talking about it, it would be it should be a negative point, and it's very high. And notice how it's 0.97. So that's really darn close to 1. Most of the time when you see correlations, when you're seeing the correlation coefficient, where you'll very rarely ever see 1, okay, negative or positive 1. You rarely see it. It's always going to be point something, okay? So let me test you out here. So if I was looking at different studies and there was a positive 0.36, a negative 0.82, positive 0.57, and a negative 0.63, which is the strongest correlation? of the 4, which is the strongest. If you get confused, the best way to deal with this is just don't look at the positive and the negative. Strongest correlation is going to be the biggest number. So of these 4, which is the biggest number? 0.82. That's the strongest correlation. Remember, positive and negative are just talking about direction. Okay? Positive means they're going in the same direction. Negative means they're going in opposite directions. All right? So if we're talking about strength, we're looking at how strong that they're related to each other. Okay? And we're going to look at the biggest number as being the strongest. So that's 0.82. So in this case, what is the weakest relationship? Weakest relationship is this one, positive 0.36. Again, ignore positive and negative. We're just looking at the numbers. 0.36 is the smallest of those 4. So that's the weakest, and this is the strongest. Okay, so another way that you can do this, so one way is to look at strength by looking at the numbers, okay, looking at the correlation coefficient. So the bigger the number, the stronger it is. Smaller the number, the weaker it is. But you can also see it if you look at the scatter plots. So remember, this one here, look how it's all over the place, okay? It's all spread out. The more spread out it is, the weaker the relationship, okay? Where the closer it is to a straight line, like this one, okay, that's very strong. That's practically a 1, okay? It's nearly a straight line. So if we go back here, okay, if you look at these two, notice how these plots are closer together than these. These are a little further apart. These are more narrow, okay? But look at the number, 0.89 compared to 0.74. Okay? So again, just by eyeballing it, the closer it is to being a straight line, you know, the stronger it is. The more spread out it is, the weaker it is. All right? So that's how you can tell strength just by eyeballing it in addition to looking at the numbers. Okay. And what does strength mean? Strength means these really are connected. These really have a really strong relationship, okay? There's something going on here. However, we've got to be careful with correlations. Correlations can be really neat. Correlations can be used to make general predictions, okay? Why do you take the SAT and the ACT tests? Okay, because there's been so much research done on those that, for example, the SAT, the ACT are predictors of what your GPA will be the first year of college within a range. That's why they're used. Okay, they've been studied so much they predict how you're going to do. Okay. Somewhat. If you're a female, it doesn't predict as well. That's a bias. We can talk about that in a different class. Just beware. It may be too late to tell you now, but if you're female, you should take the ACT, not the SAT, to get a better result. Okay, so correlations, so they can show associations. Okay, they're used for things like prediction. When you see in the paper, a newspaper or news story about recent study has shown that eating this kind of diet leads to these kinds of results. I was just hearing on the news this morning that drinking 2 or more sugary drinks a day increases the risk of premature death by some 30% or something like that. Okay, whenever you hear these studies about increases the likelihood, decreases the risk, has been associated with, has been linked to, whenever you hear those kinds of terms, that has been correlational research. Okay, where they've been looking at people and they've looked at, you know, how much sugary beverages do they drink? What kind of diet do they have? What kind of exercise have they been doing? How much television they've watched? All those kinds of things, and they look at something else. Okay. There was a study done a long time about young people who watch a certain level of television daily and how they had an increased risk of depression years later. Okay. So when you see those kinds of studies, that has been correlational research. So the interesting stuff having to do with prediction. However, correlations do not show causation. Okay? And I said, correlations do not show causation, and once again, correlations do not show causation. You've got to be very careful with that, okay? When that study came out that was just on the news today as I was driving here, sugary drinks, 2 or more sugary drinks, whether it's sodas or sports drinks, linked to greater risk of premature death, okay? Okay, it's a risk. We might automatically assume, oh, drinking 2 or more Cokes a day causes you to die sooner. Okay. Well, that could be possible, but there could be something else going on. Okay. Can you think of some other things that could be happening where people drink sugary drinks and they die earlier? That would explain both of those. People who drink sugary drinks probably also have other not so great health habits, right? Okay. So yeah, there's a link there, but is it specifically that causes it, or is that just one factor that's just stands out among a variety of things, okay? Could it be that people who are drawn to sugary drinks already have a genetic condition of one sort or another that leads them to die sooner than most people? Possibly. You might have a genetic sweet tooth, and that sweet tooth also is genetically linked to some other thing that's related to early death. Okay, we don't know for sure. Okay, what I mean by these are things called third variables. And third variables can lurk anywhere. Okay, let me give you some example. On any given day, there is a positive relationship between the number of drownings and the amount of ice cream consumed. Positive relationship. More drownings, more ice cream consumed on any given day. Now, what's going on there? What do you think? So getting back to ice cream and drownings, what do you think is going on there? What could be a third variable that it would explain why more people are eating ice cream on a given day, and also there are more drownings on a given day? Certainly we don't think, oh, people eat ice cream, they go swimming, it weighs them down and kills them. Or we don't think, oh, someone saw their friend drown and therefore they run off to Baskin-Robbins to feel better about it. You know, it's not kind of that kind of thing going on, right? But it's temperature, okay? When it's a warmer day, more people eat ice cream. Also, more people go swimming, and unfortunately, some of those swimmers may drown. Okay, so temperature is the third variable that explains both of those. Okay. Okay. Another one is there's a positive relationship between the amount of crime in a given community and the number of churches. So positive relationship means they go in the same direction, right? So more crime, more churches. Less crime, fewer churches. Okay, what could explain that? Think about that one for a little bit. What could be a third variable that would explain in any given community more crime, more churches? It's not a lot of church-going criminals. It's not a lot of people rushing to church because there's crime, although that could possibly happen. It's population. Whenever you have greater population, you have a lot more of a number of things. You could also say more street lights, more Starbucks, more schools. There's a lot more things that happen, including crime, including more churches. So population is the third variable. Okay. Now the thing is we were able to think of a third variable. Okay. There could be lots of situations where there's correlations and the third variable isn't obvious to us. But could there still be one? Certainly. Since we never know for sure if there's a third variable lurking in there that will explain why these two things are going together, that's why we cannot assume that one causes the other. Okay? We see an association. We can talk about the direction. We can talk about the strength. We can get some ideas. Sugary drinks and early death. Maybe there is something going on there. Okay? But the only way we can really talk about something causing something else to happen is with the experiment. And that's going to be a separate PowerPoint presentation for you. Okay. Just to show you some other examples, we can talk about correlations where they're called spurious correlations. If you go on the internet, you can find these. Just go to Google spurious correlations. You can get to this website. Here's an example of that here. Look at this positive relationship. Look at this. Can I open this? It's going to let me. Look how high this is. It doesn't have plus because you don't have to have plus. The plus is implied. You'd always need to add the negative though. Positive 0.9971. That's practically the strongest relationship you can get, right? It's darn near close to that perfect one. And look what's showing up here. Starting in 1998 to 2007, how autism rates have increased and organic food sales have increased. Sometimes things just are coincidences, and that's what we mean by spurious correlations. I don't think that autism causes people to eat organic food or that eating organic food causes autism, okay? Again, why you wouldn't talk about causation, right? Now, we know that between these years, we have much more information. Teachers and parents and doctors and therapists have been much more careful about diagnosing. Okay, so I think a lot of what's happened here with rates of autism spectrum, is that we've just had better diagnosing going on. Okay, so that's increased. And also, lots of people have been really interested in organic food. Okay, that these somehow are related to each other, I don't think so. I think this is just what's called a spurious correlation. It's just a coincidence. But it's a very strong one. It's very interesting. Now this is from that same spurious correlations website. And again, if you look on the bottom, I'm sorry that the correlation got cut off there a little bit. But again, another one that's really high positive, 0.99, really, really strong, practically a straight line. And look, it's Apple iPhone sales correlates with people who died by falling down the stairs. Now, maybe there's a relationship there that's causal. How many people are so busy looking at their phones that they're not watching where they're going? But I kind of doubt it. But the man who does this website looks for all kinds of bizarre things like this, and they're kind of interesting. So, just be careful as you're walking down the stairs with your phone. Watch the stairs, not your phone. If you'd like to review in another fashion this kind of information, the Headless Professor on YouTube has a nice overview of the different research methods, and I recommend that if you'd like to watch that. Okay? So looking at all these forms of research methods, it's important to know the different terms. Okay? It's important to know what happens with each, what we're doing with each. Okay? I also talked about some of the positives, what we can learn from these different kinds of research methods, but also some things we have to be careful of. For example, with case studies, you can get a lot of really fascinating information, but you can't generalize to everybody from it. Okay, it's about this person, and just one certain person, and it can maybe lead us to some other research questions and research ideas, but we can't assume from that. Okay, and so I did that with each of these, and so it's very important to review that information and to recognize that scientists are careful about finding which research approach is best for this particular topic. Oftentimes we will hear that the experiment is the best approach. And when you can do an experiment, it is the best approach. But you can't always do an experiment. There's many reasons why you may not be able to do another form of research. We can't assign people to have schizophrenia or not. Okay? There are ethical concerns, there are practical concerns for why we choose the type of research we use. And it's important that when you are a psychologist, if you're studying psychology as a psych major, you'll learn in a research methods class when is the most appropriate time and place to do this particular research method compared to that. All right? And as always, it's very important to keep in mind ethics, that you treat your research participants with respect, that you appreciate that they are helping you, and if you ever have an opportunity to be in a research study, please consider doing so, including doing things like surveys. I know some of them seem to be just for a product, but there's a lot of surveys out there where it's grad students that are working on their master's degrees or their doctoral degrees, and they really could use your help in getting those done, as well as the scientists, the many scientists, not just psychologists, but other scientists who are trying to make the world a better place, and you can help them by participating in that very important work. Thank you.